Hello class, in this lecture I will try to solve problems from Hawk's learning by using regression. So this will be chapter 13, simple linear regression. So question 1, the table below gives the number of hours 5 randomly selected students spent studying and their corresponding midterm exam grades. Using this data, consider the equation of the regression line y hat is equal to b naught plus b1x for predicting the midterm grade that a student will earn based on the number of hours spent studying. Keep in mind the correlation may or may not be statistically significant for the given data. Remember, in practice it would not be appropriate to use regression line to make a prediction if correlation is not statistically significant. So the first thing is they gave us this data hours of studying and midterm, and they're asking us to find the slope. So I will copy this data and then I wanted to download my calculation aids, so I suggest you to go to modules, module 0, and then go to calculation aids and then download copy of GB 311 chapter 13-14 calculation aids. So this calculation aids includes both chapter 13 and 14. So I changed the title to 13 and 14. Previously it was only chapter 13. So we will use the same calculation aids for both chapter 13 and 14. So we have this again. I wanted to go and copy this data. I will do copy data, and paste it here. So once I copy this data and paste it, I wanted to know which of this is X and which one of this is Y. So hours of studying is would if you study more, your midterm grades will be more. So your midterm grade will be your Y, and then your hours of studying is X. So that is what. So I will copy this Y to my data set. So here if you see, it starts with x1, x2, x3, so you need to scroll to the left to find y. So y I'll copy here, and x will be here. So one of the things is you look at, so the first thing is you look at the p-value and ask yourself whether the model is good to predict. So usually if they don't give you alpha value, you will assume alpha will be 0.05, and if this p-value here is less than 0.05, that means the model is good enough. So here if you see 0.003 is less than this 0.05, so the model is good enough to predict. So we can use this model to predict. So usually here if you see, they specified that keep in mind that the correlation may or may not be. That means they haven't checked this data for p-value. So that's the reason why they kind of gave that statement here, this whole statement, because they haven't checked what is the p-value when designing the problem. But that's okay, we will kind of at this time p-value is less than alpha. So in real world you look at this p-value and then look at the alpha value and say if p-value is less than alpha, you are saying this model is good to make predictions about the y given the x. So if study hours are given, the midterm grades can be predicted. That is what the model is saying. So currently they are asking us in the question, find the estimated slope. So what is the slope? So in here the slope is given. This is if you kind of uh, click on the right, it will tell you what it is. So this is the estimated slope B1. So I will copy this cell. So because this slope, if you see here, everything related on that row would be related to slope, and then intercept will be everything in this row will be related to slope. So currently the slope is 3.79. so I will go and paste that here. So that is the slope. How about find the y-intercept? So I go here, and if you see intercept is here, so the coefficient of intercept is our y-intercept, which is 78.51. So I will copy that and paste it here. And then find the estimated value of y when x is equal to 1. So what is the y value when x is equal to 1? So here we have prediction, I put 1. So this will be 82.30. So that is our prediction. And then determine the value of a dependent variable when at x is equal to 0. So when x is equal to 0, what would be the value? So if you see for this question, I will kind of explain in our document. So so if you see our equation of a line, we said maybe y is equal to, we used y is equal to let me see what is the question, y hat. So y hat is equal to, we said beta naught plus beta 1 x. So here in this case they are asking us to put x is equal to 0. So y is equal to beta naught plus beta 1 times 0. So this expression is 0. So y will be equivalent to beta naught. So that is y is equal to b naught. So usually beta is represented for population and b naught is represented for sample. Okay, I'm sorry I did. I will. So this is again it's b naught. I will kind of put b naught. It's the same question. I tried to do submit. I will submit it, and then the next question would be determine if the statement not all the points predicted by the linear model fall on the same line. So usually when you develop a linear regression line, something like this, so if this is your regression line, so whatever you are predicting, so if I have x value here, I predict x, y would be this one. So that means for each x value, suppose this is x1, this is x2, y would be this. So usually all the points that are used in prediction fall on that line. So usually this line is comprises of points. So all estimates, whatever you are estimating, will fall on the line. So here they are saying so not all the points predicted by the linear model fall on the same line. This is a false statement. So all the points you are using to predict should fall on your regression line. So that is what this question is. And then find the coefficient of determination for so coefficient of determination is r square. So as I discussed previously, so this will be your, so if you click, this is called coefficient of determination. So here this is coefficient of determination. So you copy this and then that's your answer. Okay, let me try again. Let me see what is did I use. Yeah, I think they changed the question. Let me check the question if it is a different question. Yeah, so the question is different, so the question is changed. So I will copy the new data and then I will paste the new data. So this is new question. That's the reason why r square is wrong. So here is the new data. Again, hours of studying is my x and midterm is my y. So I will copy those data here. I'm going to get rid of these. So my y is midterm grades, so I will copy the y. So the y is here, and then I will copy the x. So this is my x. So you see this is my r square now with the new data, coefficient of determination. So I will copy that. So this is good. So that is how you are going to solve this, and then calculate the sum of the squares of error. So this is another problem. If you see hours of studying midterm, so I will copy this now and then I will delete this and paste the new data. So let me cross check if this is new data is right. Okay, so again midterms is your y. Let me delete these first. Midterm is the y data. Copy this, paste here, and then copy this, paste here. Okay, so now this question they are asking you calculate the sum of the squares of error. Use the values beta naught as 69.08 and 5.13 as beta 1. So these values are given for you to cross check whether you are using correct x and y. So let me go and check. Beta naught is 69.086 and slope is 5.13, so that is good. So now they are asking me to calculate sum of the squares of errors. So if you see this is this residual is also called error. So sum of the squares of error is this one, so that is this value. So I will copy that, paste it here, and then the estimated variance of errors SE square. So estimated variance is this one. So if you see, this is the estimated variance for error, so you will be using the mean square error as estimated variance. So that is you will copy that 14.34, and then estimated variance of slope. So if you see in this, slope is this row, so standard error is the standard deviation of the slope. So variance, when they ask, you have to do square of it, so you have to square it. So I will do here, so this power 2 will give you the estimated value of the variance of the slope. So that means I'm squaring this term. So here it says, if you click, put there, square this value to get estimated variance. So I will do copy this and then paste it here and submit it, and then find the 99% confidence interval. So if you see, they gave you lower 95% and upper 95%. So they are asking you to calculate the 99% confidence interval for the slope, so not for the intercept. So if you type in here, this is 95%, so the slope, for the slope, 95% confidence interval will be 1.15 and 9.10, but we wanted 99% confidence interval. Just type 99%, so you will get here negative 2.16. So that is okay, let me go here. So that is this value, negative 2.16. So I will copy that and paste it here, and then the upper end point would be this one. So I will copy that and paste it here, and then 98% confidence interval they are asking again. Let me check if this problem is same. Let me check. Yeah, so now 98% confidence interval for the slope, that is what the question asks, 98% confidence interval for the slope. So I will go here and do 98%. So that is going to give me negative, I will highlight with a different color, so negative 0.54, and then the upper limit is 10.80. Again I will highlight with a different color, so I'll submit that. Again this is same problem. Now they are saying the table gives the completion percentage and interception percentage for 5 randomly selected NFL quarterbacks. Based on this data, consider the equation regression for using the completion percentage to predict the interception. So they are asking us to use completion percentage to predict interception. So our y will be interception and our x will be completion percentage. So I will copy this data and then paste it somewhere here. So the completion percentage is our x and interception is our y. So let me cross check if that is true. So they are saying, based on this, consider the equation of the regression line for using completion percentage to predict the interception percentage of the quarterback. So we are using completion percentage to predict interception. So y will be interception and x will be the completion percentage. So I will do copy this. Okay, I'll copy this and paste it here, and then copy this, paste it here. Okay, so we got this. Let me so we got all the values. So let's answer this question. So find the estimated slope. Again, this is estimated slope is I'll use a different color now. So I'll use blue, maybe light blue. Yeah, so that is our slope, negative 0.517. And then the estimate the y-intercept. So the y-intercept would be 33.45. So this 33.45 would be our y-intercept. Find the estimated value of y when x is equal to 60. So now I will put x is equal to 60 here. So that is 2.40. So I will type in this 2.40. And then according to the linear, if the independent variable is increased by 1 unit, then the change in the dependent variable is. So the idea is here, again, this is very important in regression. So if you have y is equal to beta naught plus beta 1x, so any time you increase x by 1 unit, y will increase by the slope. So y is going to increase by beta 1. So this is very simple concept. If you have an equation 2 plus 3x, so let's start putting x is equal to different values. So if x is equal to 0, y is going to be, so this is x and this is y is going to be 2. If I put x as 1, y is going to be 3 plus 2, 5. If I put y is equal to 2, this will be 8. So if you see, every 1 unit increase, y is increasing by 3 units. So that is what the slope is. So every time they ask you, if I increase x by 1 unit, what would happen? It will increase, the y will increase by the slope, which is beta 1. So in this I can say it increases by beta 1. So the next part of this is determine the value of dependent variable at x is equal to 0. If I put x is equal to 0, again y will be, let me check, x is equal to x is equal to 0, y will be beta naught. So that is this expression. So I'll check that. Find the value of coefficient of determination. So this is a different question. Again, we solved this kind of problems, so I can kind of skip this. I will try to solve one more and then I will complete this chapter. So I have a ACT score. Many universities use ACT score to help decisions as well as placement decisions. So you have an ACT score and you are calculating the GPA, so copy it. Now in these kind of problems, the problem is what is x and y. Usually the down one is y and up one is x, but to help you understand, they will give you beta naught and beta 1 if you are considering. At times it's not easy to determine which one is x and which one is y. So let me delete this and paste the okay, let me delete this and copy this data again and paste it here. So I have GPA. I will just type GPA. Let me delete this also first. I will type GPA. GPA would be my y, and then my x would be ACT score. So usually you see ACT score and so the first thing they are saying is you got intercept of 0.46 and 0.11. So you are looking at your beta naught, which is 0.46 and 0.11. They are consistent. That means our y and x are right, or the way we, yeah, so we can cross check that. Now they are asking us what is the sum of the squares of error. So the sum of the squares of error, again this is the sum of the squares of error. So I will use maybe a different color. So that would be this. So I will copy that and then paste it here, submit it. And then what is the estimated variance of error? So estimated variance is this one. So this is the estimated variance of error. So I will select that. So that is estimated variance. So I will key in here. And then estimated variance of the slope. Again, the slope estimated, this is the standard deviation of the slope. So that's the standard deviation of the slope. So I need to square this. So I will do somewhere here is equal to this power 2. So I got 0.0032. So I will copy that and paste it here. Okay, let me go copy this and paste it here. And then construct 95% confidence interval. So 95% confidence interval for the slope is this value and this value. So I will first copy the lower value. So because it says lower 95, so I will copy that here and copy this here. So if you see your negative, you have negative and positive confidence interval. That means actually your slope is 0. So because 0 lies within that limit, that means your model is not good enough to predict. So that's another way. So we will check with p-value also, but let's check with p-value for this. If this, yeah, you see this value 0.09 you have here, this is greater than 0.05. That means this model is not good enough to make any predictions. That's the conclusion you can make. Again, this value 0.0913, this is greater than 0.05. So this should be always less than 0.05. So what I'm saying is p-value should be p-value should always be less than alpha for model to be for using the model for prediction. Otherwise you cannot use that model. That model is not good enough, so its accuracy is not good. So that's the reason why r square is also becomes really less, 0.46, so it's less. So the question, we will submit this and then 98% confidence interval, so we will do 98 here. We'll type in 98, so that is negative 0.07206 and then positive 0.307, and you can submit this. So this is how you are going to solve these regression problems. This is simple linear regression. In my next lecture I will try to solve problems on multiple regression. Thank you.